Hello and welcome back to another PicoCTF challenge. Today we're going to be going over seed-sPRiNG, which is a binary exploitation challenge in which we're given a program and we're supposed to exploit it in order to get our flag. So to do this, we're going to have to split the challenge into three different parts. The first part is going to be actually reversing the executable into readable pseudo assembly code. The second part will be understanding the assembly code that we have gathered or generated. And then the third part is going to be actually scripting a script to manipulate the executable to then get our flag through an exploit. Okay, so the program that we're going to use is called radar2, and we just reference it in the terminal using R2, and we're going to use 4 A's once we actually get into it to analyze it by any means possible, and then use V to give verbose output, and we're just going to be searching through the different functions inside the assembly code and looking for anything suspicious. We do see that there was the getFlag function. What we can see here is that we have a beginning of a for loop. It's basically establishing a for loop and it's incrementing the variable by 1 each time. So now we just need to look for what the for loop is actually doing inside of it. And as we can see here, the for loop is comparing a variable to the hex 0x1e, which is just 30, so it's going from 1 to 30. Now let's take a look at the function references. We can see the getFlag function being referenced. Additionally, we see the random library being referenced and also sRandom. Another important library would be the time library, as it gives you Unix time. So additionally, we can useghydra to decompile our executable and make sure that the assumptions we made during interpreting the assembly code are correct. What we can see, or all the things we noticed, we saw that the sRandom library was being used, the random library was being used, as well as time. We can see that time is being used as a seed for the sRandom library, and we can see that the comparator is still there for 0x1e. We see that essentially what occurs is that it goes from 1 to 30 and it generates random numbers. But what the program is asking us for is for those numbers that are generated. So essentially what the purpose of our script will end up being will be to generate those random numbers and plug them into the program so then we can get the flag. A major concept to understand this challenge is the concept of pseudo-random integers, which are essentially predetermined integer values that are offset by an integer seed, which is what the sRand function is. Let's say you have an internal list of 1, 7, 8, and 9. The random function is not seeded, so when we call it, it will return that list of integers just back to back, so 1, 7, 8, 9, 1, 7, 8, 9, etc. However, if you were to seed it with an integer, let's say 3, the resulting pseudo-random integer would be the integer at the first index of the offset of the internal list. So, in our example, since we offset it by 3, it would start for the third index or the third element of the original one, except that that would be the first indice for it. So in the example, it would then turn into 9, 1, 7, 8, 9, 1, 7, 8, 9, 1, 7, 8, etc. This is where we can manipulate the executable to know exactly what values the program uses. As we saw from the decompiled source code, the program seeds its sRand function with Unix time and thus generates a new internal list every time the program is ran. However, if we run the program to generate Unix time at the same time the executable does, then we should have the same list of quote-unquote random numbers from 1 to 30, and we just have to submit them consecutively to get the flag. So now we're going to make the actual script. So as an overview of what the script is doing, we are including the time library and using it to seed sRand, so we can then generate 30 numbers using the random function. We will generate the same random numbers the executable does, and thus we'll be able to get the flag. However, before we submit the numbers, we must pass them through a bitwise AND operation, which are seen in the original executable source code as 0xf, to generate the random numbers, and so we must do the same to get the correct numbers. And after that, we are done with the script. So to run the script, we need to first compile it using GCC, which is a C code compiler, and we use C as our programming language. Once compiled, use the compiled executable and port the output into the seed-sPRiNG executable running on the server using netcat. And as you can see, we have retrieved the flag. So now we just need to copy it and submit it to get our points. Thank you for watching, and I hope you found this video informative.